All right, guys. It's Monday or Tuesday, January 11th or 12th. I am not in school Monday, obviously, because you're watching this, right? If you're in class Tuesday, I shall be there, I hope. If I'm not, you're going to have to watch this too. If you are home absent on Tuesday, you need to watch this video. Hopefully you're watching it from home so you get done what you need to get done. All right, I want to go over just a few things. Some of you haven't done anything yet. That's not good. These assignments should not take you an entire class period. They are to help with skills that you need to have to get your Algebra 2 assignments done. Okay, we need to practice them more. These are really important skills that you need for even other things outside of Chapter 5. And they're usually Algebra 1 skills that we really need to hit hard, so you're not struggling with those as well as the Algebra 2 content, okay? You should be able to get this assignment done within class. You should be working. You should not be on your phone. You should not be sleeping. If you do those two things, you will get a 0 for the day, and if that keeps up, I'm not going to let you make up the assignment. So stay awake. This should be the easiest A you get, okay? You just have to get done the assignment I give you. Then the other half of class, hopefully you get done, you got some time left, is to get that Algebra 2 assignment finished before the next Algebra 2 class. So if you weren't able to finish in class and you didn't do it as homework, then get it done, okay? So hopefully your Algebra 2 grade and your math support for Algebra 2 do really well this semester. But I wanted just to point out just a couple of things. So let me jump over to Canvas here, okay? So in the math support, whoops, my computer just froze. Last week, the module, the newest module will always be the second module, okay? The first module is important information, and I might add more pages there, but you can always minimize that one. The next module is always the current module. So this is for this week, Monday through Friday. And then last week was down here, okay? So if you did not turn in these two assignments, you're already hurting a little bit with your grade in math support, okay? So you do need to get those done and turned in. This one's blacked out because I'm in student view. If I go as a teacher and I click on this, the assignments are going to be here. They're just not here yet because I'm still recording the video and all of that. So this video is going to go right in here. We're not using rules of exponents. This is different. We're going to simplify radicals today. And then Wednesday, we'll do ascend. And then Thursday and Friday, we'll have another activity. And hopefully once I can be back in class, we'll get some activities where we can interact with each other and do something a little more entertaining and fun. But for now, you just need to do the assignment done today. So up next is the lesson video for simplifying radicals, which we have already done several times this year, but it's so important. So if you need help, ask the sub, but show your work. You will not get credit if you don't show your work. So have fun. Go on. There's a note sheet that you'll get from the sub. Take notes, then do the assignment.
All right, so we are going to simplify radicals today, but we need to first remember what parts of radicals we have, okay? So whenever you have, obviously you have the radical symbol, okay, or the root, however you want to think of this. This is the radical symbol. Okay, the number that is small and up here, okay, is called the index. Okay, so if it's the third root, that would be a 3. If it's the square root, we actually don't write anything. You can put a 2 there. It's not wrong, but we generally do not write that, okay? Fourth root, you'd put a 4 there, okay? Then you have a number inside the root, or under the root, and this is called the radicand. Okay, so the radicand is under the radical, all right? And I'll put it all together, and this is all the radical. So I guess it's not, a radicand is not under the radical. It's under the radical symbol. There you go. But all together, it is a radical. So anytime I use the term radical or root, I usually, or I am referring to these symbols, okay? And if this is, oh, I'm sorry, if the index, if I can remember what it is, index is not written, it is automatically a 2. Okay, so if there's no number here, it's automatically a square root. All right, so I'm going to show you 2 ways to simplify these, okay? The first way we're going to have is prime factorization, okay? So prime numbers are, let's see, 2, 3, 5, 7, 11, 13, and it keeps going. These are numbers you can't divide by something and get another whole number, okay? So to do prime factorization, this is where I've kind of showed you before to do like the little tree, where if I want square root of 24, I take out the smallest of the prime numbers, okay? So I go here, 24 is even, and 2 goes into it, okay? Now, 24 divided by 2 is 12, so 2 times 12 is 24, okay? Now, on the left, I'm prime, so I'm good there, but I need to look at this 12. That is not a prime number. So I find the smallest prime number that goes into it. In this case, it's 2 again. And 12 divided by 2 is 6. So 2 times 6 is 12. So I'm done with the 12. I don't need that number anymore. 2 is a prime number, so I'm going to leave it there. But 6 is not a prime number. Okay? Smallest prime number that goes into 6 is 2. So 2. 6 divided by 2 is 3. So 2 times 3 is 6, and I'm done with the 6 there. All right. So this written as a prime factorization is the same thing as saying I have a 2 times 2 times 2 times 3. Okay? So we can just go from here. You don't have to write it like this. But since this is a square root, whatever, if it has a number here, that kind of tells you how many sets or numbers you're trying to look for that are the same. Okay, this doesn't have a number, and up here we said then it's automatically a 2. So that means I want groups of 2. Not the number 2, but 2 of the same number, okay? But I happen to have 2 of the same number, and that number happens to be a 2. So that means outside of my square root, I'm going to take out 2 2's, but I only write it, since it's one circle, one group, I'm going to write it once, okay? Because 2 times 2 is 4, and the square root of 4 is 2, because these 2's are all under the root. Okay, so that was these 2 of them right here. Same set, okay? If I take them out, I just write the number once. Now, I only have 1 2 left and 1 3 left, so I have no more pairs. So I'm going to multiply those back together, and I get 6, and they're still under my square root. Okay, so that's one way to do this. The prime factorization. Get it down to all the prime numbers that you can, and then pair them up or figure out how many of each type there are and go from there. Now, another way to do this that's not prime factorization, it is taking out, so A is prime factorization. Up here, let's add a B, and we can say perfect squares. Okay? Perfect squares are numbers that you can take a square root of and get a whole number. Okay? So examples of that are, well, 2 squared is 4. So I can square root 4 and I get 2. The next number that I can square root would be 3 squared, which is 9. Okay, I can square root 9 and get 3. 4 squared is 16. 5 squared is 25. 6 squared is 36. And it keeps going. Okay? These are perfect squares. I can square root any of these numbers and get a nice pretty whole number. So that's how we get these numbers on the outside. So if I'm doing square root of 24, I want to find the biggest. So when you're doing prime factors, you want the smallest prime number. That just makes it easier. You can do any prime number, but smallest prime number makes it a little easier. Perfect squares, you want the biggest perfect square that goes into it. So I always like to look, this is 24, and 24 becomes between 16 and 25. So I'm going to start at 16 and work my way left, okay? So 24 divided by 16, that gives me a decimal. 9 doesn't go into 24, but 4 does. So I know I have a square root of 4, and 4 times 6 gives me that 24. Okay, 4 times 6 is 24, and they're both still in the roots because 24 is in the root, and they have to multiply to that number, okay? But I can take a square root of 4. If I square root 4, I get 2, and then I still have the square root of 6, okay? So those are the two methods, get the same answer. You can choose which way you do it, okay? The thing with prime factorization is we do the tree, it gets a little bigger, like when we do the 512. But 512 is also harder to find the biggest perfect square to go into it. So let's see. So let's do this one. I'm going to kind of ignore that this is here, okay? I'm going to do 512. I'll just write it here so I have room to go down because this tree will take some space. It's even, okay? So I know 2 goes into it. Okay, so 512 divided by 2 is 256. That's still even, so I know 2 goes into that. 256 divided by 2 would be, what, 128? Okay, so 2 times 128 is that 256, so I'm done with that. 128 is not prime, so I'm going to keep going. See, notice I keep the primes always on the left, so I know I just have to deal to simplify the one on the right, okay? 128 divided by 2 is 64. Again, 2 goes into 64, and it goes in 32 times. 2 goes into 32. Let's see, 16 times. 2 goes into 16 8 times, and oh, I'm running out of paper here. So I'm gonna start. All of these ones are done, and now I'm still at 8. Okay, 2 goes into that 4 times, and then 2 times 2 is 4, and I'm done. I got to a prime number. Okay, so all of these are all of those are done, but I have all these prime numbers. Now this is a square root. There's no number here. There's no index. That means the index is 2. So I want groups of 2. So I want for every group, I'm going to circle every pair of exact number or same numbers. So here's 2's. Those are the same. Here's 2's. Those are the same. There's 2's. And then that was the 8 I crossed off and rewrote. So then here's a pair of 2's. There we go. And then I'm left with one lone little 2 over here. So for every set of this, I'm going to write this number one time on the outside. So I have 2. I took care of this one. I have another one, so now it's multiplied by 2. I have another one, so now it's multiplied by 2. And I have another one, so it's multiplied by 2. And then we have the lone 2. It has to stay under the root, okay, under the radical symbol. 2 times 2 times 2 times 2. Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16 square root of 2. All right. Now, you could have taken out the biggest perfect square, but this perfect square is actually not even written here. It would be way down the line. So if you're going to use perfect squares, you want to write a whole bunch of them. Just write them all down. Okay, so this was, remember, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So the next number would be 7 squared, which is 49, and keep going, okay? All right, so let's do this last number, square root of 98. Okay, that's not obvious. That's obviously not going to be as big as this 512. But here, I'll do square root of 98 over here. Okay, it's even, so I'm going to take out a 2. All right, 98 divided by 2 would be 49. But look, right here, I have a perfect square. I know I could square root this. Plus, we're also going to get those prime numbers right now. So, it's not even, so 2 doesn't go into it. 3 doesn't go into it. It doesn't end in a 5 or a 0, so 5 doesn't go into it. But I can divide 49 by 7, and I get 7. So see, that was that perfect square right there. All right, so I'm done with the 49, and I have only prime numbers. Okay, we're going to circle our group of, or pair of them, because this is a square root. So I want 2 of the same number, and there's 2 7s. And I still have a 2 left over. Okay, since I circled 7s, that means a 7 is written on the outside. Then I have my radical symbol. And this 2 that doesn't have a pair is going on the inside. Okay, so your assignment is going to look like this. All right? So I want you to simplify the radicals. These are the answers. This is the one you're simplifying. So if I simplify, I'll even do the first one for you. So let's do 32. Get a pen here. Something to write with. All right. Sorry, I wasn't prepared, I guess. Okay, square root of 32. You have to show work if you want credit for this. Okay? You can't just fill in this picture and turn that in. I will not give you any points. You will get a 0 and have to redo it if you want the score. So make sure to be showing work. If you need to do your work on a separate sheet of paper and turn that in as well, you can do that. All right, I'm going to do this by prime factorization. If you want to do this by perfect squares, that is totally up to you, okay? But 32, smallest prime number that goes into it is 2. 2 times 16 is 32. Well, 16 is not prime, but it's even again, so I know 2 goes into it. 2 times 8 is 16, okay? 2 is prime, but 8 is not. And 2 times 4 is 8. 4 is not prime, so I get 2 times 2 is 4, and I have a prime number, all right? So that means here's a pair. This is all square roots. This whole assignment is square roots, so you're going to pair things up, okay? Now, in Algebra 2, you might get something with a different index, but right now we're just practicing simplifying these radicals, all right? So I circled one pair of 2's, so that means a 2 is on the outside. I circled another pair of 2's, so that's going to be multiplied by another 2. And I have a 2 left over, so I'm going to have a square root of 2. Okay? So 2 times 2 is 4, square root of 2. So that means square root of 32 equals this. So in my boxes, I'm looking for 4 square root of 2, which I found right here. And I'm going to color this box like this. So it looks like that's going like that. And it's shaded in here. So everyone better get this one right. I just showed you how to do it. Okay? Now again, if you wanted to do this by square roots, you would take the biggest square root that goes into that number, and its biggest square root into 36 would be 16. And 16 times 2 is 32. And because 16 was that perfect square, I can square root that, and I get 4, and I still have my square root of 2. Okay? So you can do either method. This method takes more space, but it deals with smaller numbers. This method is quick, but you got to, it takes less space, but you have to know those perfect squares, and you have to pick the biggest perfect square. All right, so now finish up this sheet. Once your picture is done and your work is all shown, get this submitted into Canvas.